Welcome to BD Daily Tech News Podcast, your daily briefing on tech and innovation. It's 2026, March 18th, and today's theme is When AI Leaves the Lab and Starts Touching the Stuff You Can't Easily Undo. National security, your eyeballs in games, and the models inside your workplace.
So basically, the Pentagon wants a chatbot, Nvidia wants to improve my face in 4K, and enterprises want to cook their own AI like it's sourdough season again. Cool. Normal Tuesday.
3 stories, tight and practical. We'll explain what happened, the simple version of the tech, and what it changes for users and developers without drifting into stock talk.
And I'll be here asking the questions you're thinking, like, is my GPU now judging my bone structure? And can a classified model be politely asked not to leak?
Story 1. MIT Technology reports the Pentagon is planning secure environments so generative AI companies can train military-specific versions of their models on classified data. The notable shift is training, not just using, models in classified settings, which raises governance and supply chain questions.
Okay, explain it like I'm 5 or like I'm a golden retriever. What's the difference between using a model on secret stuff versus training on secret stuff?
Using is like letting a consultant read classified documents inside a locked room and answer questions. Nothing leaves the room. Training is like letting that consultant rewrite their brain based on what they read, so the knowledge becomes part of the model's weights. That's where memorization risk, auditing, and what exactly did it learn becomes central.
So it's the difference between you can look but don't touch, and congrats, the model now has permanent receipts, and the receipts are classified.
Exactly. The tech behind it, you'd run training in an air-gapped or tightly controlled enclave. Think hardened data center, restricted access, logging everywhere, strict egress controls. And you'd likely need specialized evaluation, red teaming for leakage, prompt injection, and the model's tendency to hallucinate in high-stakes contexts.
Hallucinations are funny when it's my grocery list, less funny when it's analyzing targets. Also, who gets to say the model is safe? The vendor? The government? A committee with a 400-page PDF?
That's the crux. Once you train on classified data, you need strong controls over the whole lifecycle. Dataset provenance, training logs, model cards, and reproducible evals. And there's a dual-use angle. Techniques built for classified training can spill into commercial, secure AI offerings. Good for privacy, but also raises the bar for misuse.
So for normal people, the headline isn't "The Pentagon gets a chatbot." It's "The next wave of AI will be trained in locked boxes," and that changes how we think about trust and accountability.
Actionable takeaway. Adopt an AI privacy posture. Assume anything you paste into a general chatbot could be retained or reviewed unless it's explicitly an enterprise or local setup with clear terms. For developers, treat evals as a product feature. Measure leakage and robustness, not just accuracy.
Speaking of trust, gamers are apparently staging a small rebellion over Nvidia DLSS 5. I saw the phrase yassified characters, which is not something I wanted inside my tech vocabulary, but here we are.
Story 2. Coverage notes. Nvidia revealed DLSS 5, including a 3D-guided neural rendering model that can change lighting and materials in real time. The early reaction from some gamers is negative, complaints about altered character faces and an AI glow-up look rather than faithful rendering.
I need the simple version. What is neural rendering doing that normal graphics didn't do? And why does it keep accidentally giving everyone the same cheekbones?
Traditional rendering is like painting by strict rules, geometry, textures, lighting equations. DLSS-style neural rendering is like having a smart assistant that fills in pixels and details based on learned patterns, often from lower resolution inputs. If the models learned plausible faces or materials that don't match the art direction, you get that uncanny uniformity.
So it's like the game hands you a sketch, and the AI goes, "Don't worry, I've seen faces before," and then it confidently invents a face it likes, which is terrifying because it has taste.
Why it matters. For users, this becomes a fidelity question. You're not just choosing performance versus sharpness, you're choosing whether the final image is a faithful render or a model's interpretation. For developers, it's a pipeline and QA issue. You need test scenes, face and text edge cases, and toggles that don't break consistency across frames.
Actionable for gamers. If a new tech makes your favorite character look like they got a mysterious spa package, try comparing native resolution, DLSS modes, and motion scenes, not just paused screenshots, because the real crime happens while you're moving.
And for everyone, expect more model-mediated reality in consumer visuals, phones, video calls, games. The question becomes, do you want an accurate camera or a flattering one? DLSS 5 is that debate, but for real-time 3D.
All right, let's go to the office. Mistral is basically telling enterprises, stop renting vibes, build your own model, which sounds empowering and also like a lot of meetings.
Story 3. Mistral is betting on build your own AI for enterprises, training custom models from scratch on a company's own data, positioning against approaches that lean on fine-tuning existing models or using retrieval-augmented generation, also known as RAG.
I've heard fine-tune and RAG so much they've become emotional states. Give me the analogy. What's training from scratch versus fine-tuning versus RAG?
Training from scratch is writing a new textbook for the model. Expensive, slow, but you control the content and style deeply. Fine-tuning is adding a specialized chapter to an existing textbook. RAG is keeping the textbook the same, but letting the model look up answers in your company's library right before it responds.
So Mistral is selling the write your own textbook option, which sounds great until you realize your company's library is 40% PDFs named final.v7 realfinal.pdf.
That's the hidden cost: data readiness and evaluation. Custom training can pay off when you need domain-specific language, strict compliance boundaries, or offline deployment. But you need clean datasets, careful labeling, and rigorous benchmarks. Or you'll just create a bespoke model that's confidently wrong in your company's unique way.
Which is honestly the most corporate outcome possible. A custom AI that mirrors your internal jargon perfectly and still can't find the PTO policy.
Practical guidance for teams. Start with RAG plus strong access controls. Then fine-tune if you need consistent formatting or tool use. And only consider training from scratch if you can quantify the gain and maintain the model. Also budget for ongoing evals. Models drift as your data and workflows change.
So today's vibe is AI is moving into higher stakes rooms. The military wants training enclaves, gamers want their faces back, and enterprises want models that don't leak the company's secrets or its weird acronyms.
Quick recap. 1. Classified training raises lifecycle governance and leakage risk. 2. DLSS 5 highlights that neural rendering can shift from enhancement to interpretation. 3. Build your own AI can work, but only if your data and eval discipline are real, not aspirational.
If you enjoyed this, subscribe and send it to the friend who says, I don't need privacy settings. I'm boring. Congrats. Your data is still delicious to machines.
Follow for the next briefing. And if you're building with AI this week, pick one thing. Add an evaluation you can reproduce, or add a user-facing toggle that makes the system's behavior transparent. That's how we keep the future usable.